Now, how do we measure intelligence? That is standardization and the intelligence quotient IQ. The goal of the most intelligence test is to measure G, the general intelligence factor. Good intelligence tests are reliable, meaning that they are consistent over time, also demonstrate construct validity, meaning that they actually measure intelligence rather than something else. Because intelligence is such an important individual difference dimensions, psychologists have invested substantial effort in creating and improving measures of intelligence. And these tests are now the most accurate of all psychological tests. In fact, the ability to accurately assess intelligence is one of the most important contributions of psychology to everyday public life. Now, intelligence changes with age. A 3-year-old who could accurately multiply 183 by 39 would certainly be intelligent, but a 25-year-old who could not do so would be seen as unintelligent. Thus, understanding intelligence requires that we know the norms or standards in a given population of people at a given age. The standardization of a test involves giving to a large number of people at different ages and computing the average score on the test at each age level. It is important that intelligence tests be standardized on a regular basis because the overall level of intelligence in a population may change over time. The Flynn effect refers to the observation that scores on an intelligence tests worldwide have increased substantially over the past decades. Once the standardization has been accomplished, we have a picture of the average abilities of the people at different ages and can calculate a person's mental age, which is at the age at which a person is performing intellectually. Now, a number of scales are based on the IQ. The Wechter's Adult Intelligence Scale, WAIS, is the most widely used intelligence test for adults. The current version of the WAIS, the WIS-4, was standardized on 2,200 people ranging from 16 to 90 years of age. It consists of 15 different tasks, each designed to assess intelligence, including working memory, arithmetic ability, spatial ability, and general knowledge about the world. The intelligence tests that you may have been most familiar with are aptitude tests, which are designed to measure one's ability to perform a given task. For instance, to do well in college or in postgraduate training, most US colleges and universities require students to take the Scholastic Assessment Test (SAT) or the American College Test (ACT), and postgraduate school require the Graduate Record Examination (GRE), Medical College Admission Test (MCAT), or the Law School Admission Test (LAST). These tests are useful for selecting students because they predict success in the programs that they are designed for, particularly in the first year of the program. These aptitude tests also measure in part intelligence, and the Frey and Ditterman in 2004 found that SAT correlated highly between the R of 0.5 and R of 0.8 with standard measures of intelligence. Now, what is the biology of intelligence? The brain processes underlying intelligence are not completely understood, but current research has focused on 4 potential factors: the brain size, sensor ability, speed and efficiency of neural transmission, and working memory capacity. There is at least some truth to the idea that smarter people have bigger brains. Studies have measured brain volume using neuroimaging techniques find that larger brain size is correlated with intelligence. And intelligence has also been found to be correlated with all the number of neurons in the brain and with the thickness of the cortex. It is important to remember that these correlational findings do not mean that having more brain volume can cause higher intelligence. It is possible that growing up in a stimulating environment that rewards thinking and learning may lead to greater brain growth. And it is also possible that a third variable, such as a better nutrition, causes both brain volume and intelligence. Another possibility is that brains of more intelligent people operate faster or more efficiently than the brains of less intelligent people. Some evidence supporting this idea comes from data showing that people who are more intelligent frequently show less brain activity, suggesting that they need to use less capacity than those with lower intelligence when they work on a task. And the brains of more intelligent people also seem to run faster than the brains of less intelligent. Research has found that the speed with which people can perform simple tasks, such as determining which of the 2 lines is longer or pressing as quickly as possible one of the 8 buttons that is lighted, is predictive of intelligence. Intelligence scores also correlate about R 0.5 with measures of working memory, and working memory is now used as a measure of intelligence on many tests. Although intelligence is not located in a specific part of the brain, it is more prevalent in some brain areas than others. Now, Dickon et al. In 2000 administered a variety of intelligence tasks and observed the places in cortex that were most active. Although different tests created different patterns of activation, now these activated areas were primarily in the outer part of cortex, the area of the brain most involved in planning, executive control, and short-term memory. Is intelligence nature or nurture? Intelligence has both genetic and environmental causes, and these have been systematically studied through a large number of twin and adoption studies. These studies have found that between 40% and 80% of the variability in IQ is due to genetics, meaning that overall genetics plays a bigger role than environment in creating IQ differences among individuals. The IQs of identical twins correlate very highly, that is, R is equal to 0.86, much higher than to the scores of fraternal twins who are less genetically similar, that is, R is equal to 0.60. And the correlations between the IQs of parent and their biological children, that is R 0.42, is significantly greater than the correlation between parents and adopted children. The role of genetics gets stronger as children get older. The intelligence of very young age and young children is less than 3 years old, does not predict adult intelligence, but by age 7 it does, and IQ scores remain very stable in adulthood. But there is also evidence for the role of nurture, indicating that individuals are not born with fixed, unchangeable levels of intelligence. Twins raised together in the same home have more similar IQs than do twins who are raised in different homes, and fraternal twins have more similar IQs than non-twin siblings, which are likely to do the fact they are treated more similarly than our siblings. The fact that intelligence becomes more stable as we get older provides evidence that early environmental experience matter more than the later ones. Now, if impoverished environments can harm intelligence, we might wonder whether enriched environments can improve it. Government-funded after-school programs such as Head Start are designed to help children learn. Research has found that attending such programs may increase intelligence for a short time, but these increases rarely last after the programs end. But other studies suggest that Head Start and similar programs may improve emotional intelligence and reduce the likelihood that children will drop out of school or be held back at a grade. It is important to remember that the relative roles of nature and nurture can never be completely separated. A child who has higher than average intelligence will be treated differently than a child who has lower than average intelligence, and these differences in behavior will likely amplify initial differences. This means that modest genetic differences can be multiplied into big differences over time.